In this video, we're going to be looking at finding the highest common factor and the lowest common multiple of a pair of numbers, but these numbers are now so big that we don't want to use the method we used in an earlier video. We don't want to be listing all the factors of these two numbers and then looking for the highest one, because that would take us a long time. Similarly, we don't want to start listing out the numbers in the 672 and the 600 times table, or the multiples of those numbers, because that will take a long time. So we're going to use a better method, and this involves using the prime factor decompositions of these numbers. Now, if you need more practice on prime factor decompositions, I recommend you go back to video 4 or check out bossmaths.com/N4C for more detailed videos. So continuing with this video, you should be comfortable breaking these down or decomposing 672 and 600 into products of prime factors. Pause the video and have a go at that for yourself. What you should have found is that 672 is 2 times 2 times 2 times 2 times 2 times 3 times 7, and that 600 equals 2 times 2 times 2 times 3 times 5 times 5. Now, I haven't written those using indices, so I'll just write them out, but I'm going to try and line up the prime factors like this. So for 672, I've got 2 to the power of 5, and for 600, I've got 2 to the power of 3, and I'm going to write that directly underneath to line up those powers. In 672, I've got a 3 to the power of 1, so I'm going to multiply that by 3 to the power of 1. In 600, I've also got a 3 to the power of 1. And notice I've lined up the 3's. Now, I've also got a 7 in the 672, and I've got 5's in 600. So I'm going to write the 5 to the power of 2 here, and I'm going to leave a little blank there and write multiplied by 7 to the power of 1. So I've now taken account of this 7 as well. Now let's think about finding the highest common factor of 672 and 600. Straight away we can see that 2 is a common factor. Now, it's not the highest, but it is a common factor. 2 clearly goes into 672 and 600, and we can see that because we've got a 2 in these products here and here. It's not the highest though, because what if I considered 2 times 2 like that? What I've highlighted is effectively worth 4. So 672 is clearly 4 times whatever that lot is, and 600 is 4 times whatever that lot is. So 4 goes into both 600 and 672. So that's a common factor, and it's higher than just 2 on its own. So great, but can we do better? Well, yes, we can. What if we now highlighted everything that we could find that's in both lists? So I've got a 2 and a 2, I've got another 2 and another 2, I've got a 2 and a 2 there. So far, hopefully you can see that we've got 8 times whatever that lot is, and 8 times whatever this lot is. So 8 is clearly a common factor, but it's still not the highest, because I can also highlight a 3 there and a 3 there. And if we multiply all of these together, 2 times 2 times 2 times 3, you can see that I get 24. And 24 times whatever this lot is 600. But also 24 is a factor of 672, because I could do 2 times 2 times 2 times 3. That would give me 24, multiplied by 2 times 2 times 7, whatever that works out to be, would be 672. So 24 is a higher common factor. And in fact, we can't do any better, because I can't find any more prime factors that are in both lists. Now, A better way of doing this would be to use this form here. What we do is look for prime factors that are in both lists, and you can see that I've got 2s and 3s in both. I haven't got a 5 in both, and I haven't got a 7 in both. So our highest common factor is going to be 2 to some power multiplied by 3 to some power. And we just have to decide what indices to use. What we need to do is pick the lower of the two indices for each of these prime factors. So 2 to the power of 3 and 2 to the power of 5. Well, 3 is lower than 5, so we're going to pick 3. And for this prime factor, for the 3, we're going to look at the indices. We've got a 1 and a 1. Well, they're both the same thing, so the lower is just 1. So the highest common factor is 2 cubed times 3 to the power of 1, and that is simply 24. Some teachers like to teach this using Venn diagrams, so I'll just quickly demonstrate what that looks like. What we need to do is fill in the prime factors of 672 and 600. It's easiest to start with what they've got in common. So each of these have got 3 2s and a 3 in common. So I'm going to put in 3 2s and a 3 like that. Now 672 has also got another 2, a 2 and a 7. So another 2, a 2 and a 7 go in there. And 600 has got a 5 and another 5. So they go in there. Now this is really important to understand. What we've got in this set is the prime factor decomposition of 672. If I multiply all of these numbers together, 2 times 2 times 2 times 2 times 2 times 3 times 7, I'm going to get 672. I've just said what we wrote out here. And if I now multiply all of the numbers in this set, I will get 600. 2 times 2 times 2 times 3 times 5 is just this here. The highest common factor is what we've got in this intersection, or this overlapping part. 2 times 2 times 2 times 3. It's basically what we've highlighted, or what we did over here. 2 cubed times 3 to the power of 1. That's 2 times 2 times 2 times 3. Now let's look for the lowest common multiple. The lowest common multiple has to be a multiple of 672 and a multiple of 600. Now, if it's a multiple of 672, it has to be a multiple of all of this lot, because this is 672. That means whatever the lowest common multiple is, its prime factor decomposition has to have at least 2 to the power of 5, 3 to the power of 1, and 7 to the power of 1 in it. But the lowest common multiple also has to be a multiple of 600, which means it has to have at least 2 to the power of 3, 3 to the power of 1, and 5 squared in it. And I'll illustrate what we're effectively doing by copying this information down here again. So, as we've just said, the lowest common multiple has to have all of these prime factors, including the 5 and the 7, and the indices have to be at least all of these numbers here. So we have to have 2 to the power of at least 3 and at least 5. Well, that means it has to be 5. We want to take the bigger of those two, because if it has to be at least 5, it can't be 3. Then we multiply that by 3 to the power of whichever is bigger out of these two. Well, they're both the same, so we just pick 1. Then we're comparing 5 squared with, well, this 5 to the power of nothing effectively, so we need 5 to the power of 2. And finally we're comparing 7 to the power of 1 with 7 to the power of nothing effectively, so we need 7 to the power of 1. Notice that what we've just written is actually the product of all of the numbers in this Venn diagram. 2 to the power of 5 is just 2 times 2 times 2 times 2 times 2. Multiplied by 3 to the power of 1, that's multiplied by this 3. Multiplying by 5 squared is multiplying by that 5 and that 5. Multiplying by 7 to the power of 1 is multiplying by that 7. So if you've drawn the Venn diagram, you can find the lowest common multiple by multiplying all of the prime factors that are inside it. Just to illustrate what's going on there, I'm going to quickly highlight what you need to multiply together for each of these questions. For the highest common factor, you are just multiplying these numbers together, so those that are in the intersection or the overlap. If you're looking for the lowest common multiple, what you need to do is multiply all of these numbers together like this. Now, there is a bit of a shortcut you can take if you're using a calculator, which you probably will be for a question like this. You don't actually need to type out 2 times 2 times 2 times 2 times 2 times 3 times 7 times 5 times 5, because if you think about it, everything in this circle you know multiplies to 672. That was the whole point of this Venn diagram. So you could simply type in 672 times 5 times 5, and that would give you the same answer as we get here. So whichever way you do it, if you pop that into your calculator, you will get 16,800.